Okay, Unit 1A, Day 7. We're going to start our proofs. So algebraic proofs, we have some properties here. They're called properties of equality. We can also abbreviate that as POE instead of writing that every time through our proofs. The first one, addition property of equality. So if I had something like A equals B, well, if I added another letter to each side, so A plus C, if I added C to this side, and I added C to this side, then they would still cancel each other out, so I'd be back to A plus B. Similarly, subtraction, property of equality. If I had A equals B, then if I subtracted a number on each side, whatever number, as long as I did it on each side, then I would be still balancing that equation, property of equality. Multiplication, if I had A equals B, and I times both sides by the same number, then I would still be having equal sides. So if I multiplied the left and right both by C, then I could still get back to A equals B. Similarly, division, A equals B. Then if I divide both these pieces by C, then I get back to where I started. Next, something you're probably more used to using. If I had A and then parentheses B plus C, then A times B plus C is equal to me distributing these two things. So A, B plus A times C is AC. That is distributive property. Even though these are properties of equalities, we for the rest of these, we don't have to write property of equality, we just write distributive property, substitution property. So this next one, if A equals B, then A may be replaced by B in an expression or equation. Okay. Reflexive properties, so that means the number is going to be equal to itself. So for any real number A, then A equals A. It equals itself. Symmetric property. So that means if I have A equals B, then that's the same thing as B equals A. I'm flipping the sides. However, in our proofs that you'll see, you have to, if you flip the sides like this, you have to denote that was the symmetric property. Transitive, this is a really important one. So if A equals B and B equals C, then notice if A is B, B is C, then A is C. A equals C. So both of these have B. If A is B, B is C, then I could take these other two sides and set those equal to each other, and it would be a true statement. This is one of our most important properties that we use. Okay, using the properties of equality. Properties of equality can be used to justify steps in solving an equation. So today we're just going to do straight algebraic, so doing multi-step equations and writing out our steps. So we're doing two-column proofs. It's a common format used to organize our proofs. The left side will always be called, it's our steps, so we call it our statements. Our statements, and then the right side is justifying the steps, so this is the reasons. Statements and the reasons. Kind of got cut off in this one, so if you wanted to write here, statements and reasons. Notice there's two columns here. Notice they're numbered 1, 1, 2, 2, 3, 3. So what can we use as a reason? We can use these properties, all these that we did above. We can use a definition. It's like saying something is 90 degrees. Well, if it was perpendicular, then definition of perpendicular. Postulate and a theorem. So remember we did angle addition theorem and segment addition theorem already? Okay, so let's go through the first one. Example 1, It said given 4x minus 1 equals 27. Every single first step is always the given. So here's what they gave us, here's the given. That's always going to be given on step 1. We're trying to prove that x equals 7. Okay, so if I have this equation, my first step is going to be to add 1 on both sides. This is the step that I want us to stop stop showing. So what did I do? I added 1 on both sides, and I got to here. 4x equals 27 plus 1 is 28. So that was the addition property of equality. Now, you don't have to write property of equality every time, you can write POE. Then one more thing, to get x alone, I had to divide both sides by 4, and I got x equals 7. So how did I get there? I divided. Oops, it's actually called division. How did we get there? We divided, but what's the property called? Division. Property of equality. I was trying to prove that x equals 7, so that better be my last step. They look identical. Flip to the next page. Okay, we have a over negative 6 plus 2 equals 5. That's my first step. It's my given. I'm trying to prove that a equals negative 18. So my first step, what's different? Okay, well this 2's not there. It must have been on the other side. So how do I get 2 to the other side? I subtract. So that would be called subtraction, POE. All right, now I have this, trying to get a alone. So I should be multiplying both sides by negative 6. So multiplication, property of equality. When I multiply both sides by negative 6, a is left on the left. 3 times negative 6 is negative 18. I have made it to the step that I was trying to prove. So I'm done. Really all we're doing is a multi-step equation, writing our steps. We're trying to prove our final answer, so you can write your steps to that. We're building up to more. So this may seem really easy today, but we're building up to more. Okay, so we have a longer problem here. The very first step is this entire equation are given. We are trying to prove that x equals 2/3. So notice, I don't want decimals. So I'm going to walk through this. First step, given. From there to our second step, let's think about what we should do with multi-step equations. We should distribute inside those parentheses. So that's called distributive property of equality. Or just distributive property. All right, from here, I know that I should be combining the things that are alike. So here I've got x's and x's on the same side. Negative 7 plus 4 is negative 3. So all I did was I simplified. Or you can also consider that combine like terms. Number 4, well, we have a couple different steps we could take. From here, I could combine my x's together, or I could combine my constants together. Okay, that is your choice. However, on this one, we have the filled in left side, so we have to see what they did. Okay, so they went from x's on both sides to only x's on the left. So they took this 12x and moved it to the left through subtraction. Negative 3 minus 12 is negative 15. So that was subtraction, POE. Then they took this 14, added that to both sides, and got to this step. So we're thinking, how did we get to this step? Well, we added 14 to both sides, so addition, POE. The next one, how did we get to step 6? Well, we divided both sides by negative 15, and then we reduce that fraction. So this could be seven steps if you just left it as 10 over 15, but they reduced in the same step. So we can just call it division, property of equality. Now let's step it up a notch and let's complete both sides ourselves. So it says complete the statements and reasons. Step 1, always writing the given. So we have 2 times x minus 9 equals negative 10. Step 1, given. Step 2.
At this time, football players need to be released. They'll be fetching a bus at the front.
From here on the left side,
to the high school.
I must distribute 2 into these parentheses. So before I even do that, I can just write down what I did. I will be doing the distributive property. So 2 times x is 2x. 2 times negative 9 is negative 18 equals negative 10. Step 3. Let's look again what we're trying to prove. We're trying to prove that x is 4. Not quite there yet. Trying to get x alone so I can move this 18. I will be adding it to both sides. So addition, property of equality, we're doing it to both sides. So add 18, so 2x equals negative 10 plus 18 is 8. One more step to get x all alone. I have to divide both sides by 2. So division, POE. So dividing both sides by 2, x should be 4. Notice this and this match up. I'm done. Double check that you've numbered these correctly, 1 through 4 here, 1 through 4 here. Step 2 is how I got there. I used the distributive property. Pause the video, try number 4 on your own, and then check it with me. Okay, now that you've done number 4, step 1 is always writing out our given. 5y minus 1, all of that divided by 2 is equal to 7. So step 1, given. I'm trying to prove that y equals 3. Let's try it. Step 2, I want to get rid of this fraction, so I'm going to multiply both sides by 2. So that would be multiplication, property of equality. So let's do that. When I multiply the left side by 2, I'm just left with 5y minus 1 equals. When I multiply the right side, I get 14. Now, trying to get y alone, let's move the 1 to the other side. We do that, it's minus, so we can do that through addition. So 5y equals 15. Divide both sides by 5 to get y alone, so division. Property of equality, y equals 3. These match. I'm done. Okay, you do have some homework problems on this, which you can find on Canvas. If you flip it over to the next page. So I wanted you to have this early. These don't really go with today's notes. They more so go with tomorrow's notes. However, I would like you to take a second and look at these. Because the reflexive property we showed you with numbers like a equals a, sure. Okay. However, for any segment AB is congruent to AB. So I'd like you to just take a look at these and what they look like talking about segments. Transitive property. A is congruent to B. Symmetric. A is congruent to B, then B is congruent to A. Transitive, if A is congruent to B, B is congruent to C. Both of these are congruent to A and C, so A and C are also congruent. We can talk about them with segments all through here, read over those, and then we can also talk about them with angles. We won't use all of these this unit. Some of them, such as vertical angles, we'll use next unit. Just start to become familiar with these before next class.